video, we'll look at some more big circle problems. I'm going to start by jumping right into this first example and labeling all the information that they give to me in the problem. I'm going to take that information and label them in my diagram. And because they gave me some of the arcs, but not all, the very first thing that I'm going to do is go find the remainder of the arcs. They do tell me that segment AB is a diameter. So I know because segment AB is a diameter that if I start at B and go all the way around to F, the total of that blue arc has to be 180 degrees. That makes the measure of arc AF equal to 75 degrees. So I'm going to go ahead and label that one. And likewise, if I start here at point F and go all the way around on that purple arc and end up at point B, I know the sums of all the arcs along that purple arc have to total up to 180 degrees. So now I can use that fact to go ahead and determine the length of arc CD. And I find the length of arc CD to be equal to 80 degrees. So I'm going to go ahead and label that also. Because now that I know the measures of all my arcs, I'm ready to get down to business here. All right, rather than label or answer the questions down in the blanks at the bottom, I'm going to label them in the diagram, and that's just so that I don't make anybody dizzy scrolling up and down on the screen. All right, angle 1. He's an inscribed angle. His vertex is on the circle. The rule for an angle who's on the circle says the degree measure of the angle is equal to half of the intercepted arc. Well, the intercepted arc for angle 1 starts at point B and ends at point D. So half of that 130 degree arc is going to make the measure of angle 1 65 degrees. And I'm going to label that in my picture, and you should too, even if you write the answers in down below, because angle 1 might help you find somebody else's degree measure. All right, I'm looking at angle 8 right now, and I'm going out of order because I'm seeing this and I want to keep the ball rolling here. Angle 8, like angle 1, has his vertex on the circle. His degree measure is going to be half that of his intercepted arc. The intercepted arc for angle 8 starts at point A, ends at point F. So 75 degrees divided by 2 is going to make the degree measure of angle 8 37.5 degrees. I'm going to go sneak a peek and see if anybody else has their vertex on the circle. Angle 10 has his vertex on the circle, but the tricky part of angle 10 is that one of his sides doesn't intercept an arc. So unfortunately, I have to save that one for later because I can't use the same strategy that I used with angle 1 and with angle 8. Moving around the circle, angle 9 has his vertex on the circle. I know his angle measure is going to be equal to half that of his arc. His arc starts here at C and goes all the way around to point F. So his arc is going to be that 75 plus the 105 plus the 50. His arc is going to be 230 degrees, making the measure of angle 9 115 degrees. All right, so that takes care of everybody whose vertex is on the circle. I'm going to go look at angle 3 now, whose vertex is at the center of the circle. He's a central angle. The rule for the central angle says his degree measure is equal to his intercepted arc. So his intercepted arc here is arc BC. The degree measure of angle 3 is therefore going to be 50 degrees. Angle 2 has a vertex that's outside the circle. The rule for an angle whose vertex is outside the circle is that his degree measure is equal to half the difference between the two arcs. So measure of angle 2 is equal to half of the difference. Well, the difference between what? I need to go and find those two arcs. So the larger of his two arcs is going to start at A and end at F. So the larger of the two arcs is going to be that arc all the way from, E to A, or 110 degrees. The smaller of those two arcs is going to be 50. So half of the 110 subtract 50, making the measure of angle 2 equal to 30 degrees. All right, I'm going to move on to some of the other angles in the picture. I'm going to go tackle now angle 7. Angle 7 has his vertex inside the circle, but not at the center. So the rule for that says the measure of the angle is equal to half the sum of the two arcs. So I need to go find the two arcs for angle 7. So looking at angle 7, one of those two arcs is going to be the arc that starts at C and ends at D, or 80. The other of the two arcs, remember, we find by looking at his vertical angle pair. So his vertical angle is that little purple guy over here, and his arc starts at A and ends at E. His arc is 110. So half the sum of 80 and 110, making the measure of angle 7 equal to 95 degrees. Well, looking at the picture, angle 6 is supplementary to angle 7. Together they form a linear pair and make a straight line. So I can now find the measure of angle 6 by subtracting 95 from 180. So that makes the measure of angle 6 equal to 85. All right, so I'm pretty happy about the way that this is going. I'm knocking these right out of here. Angle 4, similar to angle 7, he has his vertex inside the circle, but not at the center. So the rule for that says the angle measure is equal to half of the sum of the two intercepted arcs. So one of the arcs for angle 4 is going to be arc AF, which is 75 degrees. The other of the arcs, remember, you're going to find by taking the vertical angle. So the vertical angle's arc starts at B and ends at D. So the degree measure of that arc is 130. So half the sum of 130 and 75. So I'm just going to take a minute and go plug that into my calculator. So that angle is 102.5 degrees. His vertical angle is 102.5 degrees also. And then looking at the picture, angle 5 is of course supplementary to angle 4. So I'll find the measure of angle 5 by subtracting that 102.5 from 180, making the measure of angle 5 equal to 77.5 degrees. All right, the only one that I need to go back to now is angle 10. Angle 10 is a tough one to find because only one of his sides has an intercepted arc. But if I look at the quadrilateral formed by those purple line segments, I do remember that in a quadrilateral, the sum of all the interior angles has to total to 360 degrees. And right now, I know 2 out of the 4. I know this little guy over here, angle 3, has a degree measure equal to 50. His supplement, which is inside that quadrilateral, is going to have to be 130. So now I can go ahead and find the degree measure of angle 10 just by subtracting all the other angles in that quadrilateral from 360. And I find that the degree measure of angle 10, when I do that subtraction, the degree measure of angle 10 is 42.5 degrees. All right, so at this point we have found them all, and I'll call it a good job well done. Like always, I want you to make sense of this video in your mind by summarizing the key ideas and the important understandings in your own words, and then see if you can apply what you know in order to solve the big circle problems on page 22.